Hey, hello. So, going to do the homework. I'm actually only going to do one homework from section 7.1. I'm going to do question 6, question 7.6. So the page is 518, and it asks us to calculate the chi-squared value and then to look up the resulting p-value. So that's the key parts of calculating what we need to calculate. So here we go. Um, I'm again on page 517, and the directions say in these exercises, the categories of a categorical variable given are along with the observation counts from the sample. The expected counts from the null hypothesis are given in parentheses. Compute the chi-squared test statistic and use the chi-squared distribution. So they basically want me to find chi-squared and then look it up on the appropriate table. Right? And the actual exercise is, I know you have it in your book, so it doesn't matter that it's difficult to read here. It says category A is a 61, a 35, and a 54. And then in parentheses, they happen to have written the expected counts. So they're expecting this to be 50, 50, 50. That is to say, they're expecting all three to occur with equal frequency. 50, 50, 50 would be that A has a 1/3 chance of happening, B has a 1/3 chance of happening, and C has a 1/3 chance of happening. Okay. Okay, good. So I'm going to, of course, pop up stat key, and we're gonna find what is the chi-squared value. We're going to calculate what is the chi-squared value, and then we'll use that to look it up on the chi-squared place. So here I am in chi-squared goodness of fit, and that's how I'm going to calculate the chi-squared value. I'm going to enter the data into stat key if I can remember the data, if I don't flub it up. Okay, so it comes up with rock, paper, scissors, but it doesn't matter what it comes up with because I'm going to edit the data. And the data that I want to edit is 61, 35, 54. So 61, 61, and that's for category A. Went the wrong place. Category A. Category B is 35. Category B is 35. And category C is, what is it now? 54. Category C is 54. C is 54. Okay, so I think I did that right. 61, 35, 54. Looks right to me. Okay, and there it is, 61, 35, 54. Now again, the question has said that the expected values are 50, 50, 50, so I got to change the null hypothesis to say even, 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 and it already says 1/3, 1/3, 1/3. Just happens to be the way stat key comes up. Okay, so I'm not going to change these. These are 1/3, 1/3, 1/3. Can you see that says 0.333? Okay, so then stat key has calculated for me the chi-squared value. A person could see it's up there, 7.20. I'm going to show the details of the calculation because, again, I'm trying to give the idea that these don't come from crazy nowhere. They make some kind of sense. And here's the details of the calculation. Excuse me. There's the category A, the category B, and the category C. 61, 35, 54. If they were indeed 1/3, 1/3, 1/3, then they would be 50, 50, 50. Those are the numbers in green. And then to calculate the number in blue at the bottom, you take 61 minus 50, square it, and divide by 50. 61 minus 50, square it, and divide by 50. So a mildly complicated formula, but not brutal. Gives you 2.42. 35 minus 50 squared divided by 50 gives you 4.5. 5.4 minus, excuse me, 54, sorry, 54 minus 50 divided by, 54 minus 50 squared divided by 50 gives you 0.32. Add 2.42 plus 4.5 plus 0.32, and you get this number over here, the number I have to remember till I get to the next screen, 7.240. 7.240. So 7.240 is exactly like the z-score or the t-score. It stands for how far we are from the expected outcome. 7.20 doesn't sound like a whole lot, but maybe it is. We'll see. We got to look it up. 7.240, and we'll go to the chi-square table just like we went to the normal table or like we went to the t-table. We'll go to the chi-square table and we'll say 7.240, what's the associated p-value? Okay, here I go. So I got to go just like I would have gone to the normal curve or would have gone to the t-curve. Now I'm going to go to the chi-squared curve. So here I go. Degrees of freedom is 2 because there were 3 categories, category A, category B, and category C. And we got a curve that falls off sharply, and I'm looking for what, 7.24. 7.24. So right tail, 7.24. 7.24. And says the p-value is 0.027. Can you see it there? 0.027. So it was about 2.5%, a little less than 3%. So so the p-value was at least reasonable. We did a couple problems in the previous video where the p-value was crazy small. Here the p-value is something like 2.5%, 3%. So it's more sort of everyday kind of thing, but still a p-value of 2.5%. If alpha equals 0.5, we would reject H naught. On the other hand, if alpha equals 0.1, we would fail to reject H naught. Again, if alpha equals 0.5, we would reject. If alpha equals 0.1, we would fail to reject. So this is, again, trying to emphasize the way these things are alike rather than how they are different. To get the number to look up, I use this screen, the chi-squared goodness of fit. Once I get that number, I go over to the theoretical distribution chi-squared. I enter degrees of freedom equals 2 because there are 3 categories and you got to subtract 1. And then right tail, the number from the previous screen, that tells you the p-value. Okay. Okay, so again, trying to emphasize how these things are like this is a hypothesis test. No confidence intervals here. This is a hypothesis test. So we are trying to see, is the sample we observed so far from what we expect that we find what we expected is hard to believe? Or is the sample that we observe perfectly everyday variation? In this case, the 2.7, the p-value of 0.027, a 2.7% chance of happening, is getting on the rare side. Not ridiculously rare like the other ones we saw in section 7.1, but getting on the rare side. So it would depend. Is alpha equals 0.5 or alpha equals 0.1 sort of thing, whether you reject H naught or fail to reject H naught. Okay, very good. Okay, bye-bye.